Hey guys, Paul here today, and today we're going to be looking at solving some two-step equations. Now I think I may divide this into two videos, so we'll look at the first video now, and then I'll do another video in the future. Okay, so anyway, let's get started on two-step equations. Some of you may be like, oh, I'm so scared. You don't have anything to be scared of, man. Don't worry, man. Hold my hand and I'm going to show you the way how to get through this. Okay, so let's do this. So let's see an example here. We've got 2x plus 4 is equal to 6. Okay, now it's called a two-step equation. It's called a two-step equation because you're doing two things to the x. You are multiplying the x by 2, which is the 2x, and you're also adding 4 to the x. Okay, now if you guys remember your BIDMAS, your brackets, indices, division, multiplication, addition and subtraction, you basically kind of need to do almost the opposite of the order of operations that you'd usually do. So for example here, we are timesing the x by 2 and we're also adding 4 to the x. Now if you look at what comes first in the order of operations, the BIDMAS, so we got multiplication and we got addition. Okay, if you look at what comes first, multiplication comes first before division. But when solving equations, we're going to kind of do things the opposite. Okay, so instead of solving the multiplication first, we're going to solve the addition first. Okay, so we need to get rid of this plus 4 first. So in order to get rid of that plus 4, what do you need to do? You need to take away 4 from both sides. So take away 4 from that side, take away 4 from that side. Okay, so if we take away 4 from this side, we're basically going to be getting rid of this plus 4. Okay, and we're going to be left with 2x. Okay, and we're going to get 6 take away 4, that's going to leave us with a 2. Okay, sorry about that. Yeah, so now we've got 2x is equal to 2. We need to get rid of this 2, guys. We need to get rid of this 2. What is that 2 doing to the x? It's multiplying, but it's multiplying the x. So the inverse operation of the multiplication is division. So we need to divide both sides by 2, because remember, whatever we do to one side, we need to do to the other side. Okay, so that's going to get rid of that 2. We're just going to have x is equal to, just so you know, 2 divided by 2 does not give you 0. 2 divided by 2, how many 2's go into 2? 1. It's going to give you 1, okay? Because I know some people will be tempted to say 0, and it's not. Okay, now let's look at another example. Let us have 3x take away 7 is equal to, let us have 23. Okay, so 3x take away 7 is equal to 23. So again, if we look at the order of operations, we know that multiplication comes first and then subtraction comes after multiplication. But remember, we're working backwards. So if we're working backwards, subtraction comes first and then multiplication. Sorry about that. I don't know what is going on there. So we need to get rid of the minus 7, guys. So in order to get rid of the minus 7, we are going to basically add 7 to both sides, add 7 to that side, and add 7 to that side. If we add 7 to that side, it's going to get rid of our minus 7. And we're just going to be left with 3x. 3x equal to, let's see, so we got 23 plus 7, which gives us 30. Okay, now we are timesing this x by 3, so we need to do the inverse operation of multiplication, which is divide. So we need to divide both sides by 3, divide that side by 3, and divide that side by 3. That's going to cancel that out, and we're just going to have x is equal to 30 divided by 3. Come on, people, what is 30 divided by 3? It is actually 10. Lovely. Okay, so we've solved this two-step equation. We've got it down to x is equal to 10. Lovely, 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 jubbly. Woo-hoo! Okay, let's look at two more examples very, very quickly. So I'm just going to write down, let's have 4x plus 5 is equal to, let us have 25 on that side. And then on this side, we're going to have 7x take away, that's meant to be an x, 7x take away 3 is equal to, let's have 18. Okay, so let's look at this side first. So again, we've got multiplication, we've got addition. Which one comes first? Or since we're working in reverse, the addition, we need to sort out the addition first and then the multiplication. So we need to get rid of this plus 5. To get rid of the plus 5, you need to take 5 from both sides. Because whatever you do to one side, you need to do to the other side. So that plus 5 and that minus 5 will cancel each other out. So we're just left with 4x is equal to 25 take away 5 is going to give us 20. So now we've got 4x equal to 20. We need to get rid of this 4. And this 4 is multiplying by the x. So what's the inverse operation of multiplication? It is actually division. So we're going to divide this side by 4 and we're going to divide this side by 4 as well. Okay, so that's 4 is going to cancel that 4 out. We're just going to be left with x is equal to 20 divided by 4 is going to give us 5. Lovely, that is our answer. We've solved the equation. We've got x equal to 5. Now we're going to look at this side here. 7x minus 3 is equal to 18. So we need to get rid of this minus 3 first. So therefore we're going to add 3 to both sides. That's the inverse of subtraction is addition. Okay, so we're just going to be left with 7x is equal to 18 plus 3 is going to give you 21. So now we've got 7x equal to 21. We need to get rid of this 7 times x. So therefore we need to do the inverse operation of multiplication, which is division. Lovely. So we're going to divide both sides by 7, divide that side by 7. Lovely. So that's going to cancel that out, and we're just going to be left with x is equal to 3, because 21 divided by 7 is giving us 3, and that is our equation solved. Okay, so anyway, I hope you guys understood that a little bit clearly. I hope you can now solve two-step equations by yourself. Yeah, so leave a comment below on how you understood that. If you didn't understand that, if you want me to explain it again, then I'm sure to be able to do that. Okay, well, anyway, guys, have a good day, and thank you for tuning in into Paul's Maths Lab. Woohoo!